So in today's video, we're going to go ahead and take a look at the definition of absolute extremum. And so this is very similar to kind of relative or local extremum, but in this one, we come to find that this is the greatest maximum or least minimum value a function attains over its domain. So the greatest maximum or the least minimum value. And so essentially, the way that this kind of differs from when we're actually taking a look at relative extremum or local extremum is that this is the greatest relative extremum or the least relative extremum, right? Or so the greatest relative maximum or the least relative minimum is one way you could think about it. And there are going to be certain cases in which our function does not actually attain an absolute maximum or an absolute minimum. Maybe it just continues on to infinity, as we'll come to find. And so let's take a look at a couple of examples over here. And so in this first example I drew out, we have an example of a function that's defined over an interval. So this is defined over the interval a, b, right over here. So these are the two endpoints of our interval. And what we're going to do is we're going to take a look at the global extremum or the absolute extrema of this function over this domain, right? Because it's not really defined for anything outside of a and b. We're only confining it to just this particular interval. And so let's go ahead and actually do that. And so over here, if we were to take a look, first of all, at kind of these sort of dips and bends within the actual function or within the actual domain, we can go ahead and mark a couple of points that look to be stationary points, right? That look to have a horizontal tangent line. So we have maybe this point right over here. We have this point up here, this one down here, and maybe this one. So these are all, stationary points. Why is that? Because it looks as though we have a horizontal tangent line at every one of these points. Right? And if we want to kind of just think about the derivative of this function, we could just kind of analyze it by looking at it. But if you want to think about its derivative, we can see how, like, over here, the slope of the tangent line is negative, and then we reach our horizontal tangent, and then it's positive. So we go from decreasing to our stationary point and then to increasing. And so because of that, we can say that over here, we're going to have a minimum point, right? A minimum value. And let's go ahead and take a look at these next couple of points. So this point right over here, we're kind of increasing, we reach our horizontal tangent, and then we start decreasing again. And so it looks as though we have let me actually write relative minimum, and here we'd have a relative maximum. And then same thing down here, we have kind of a decreasing or negative tangent, a negative slope for our tangent line. We reach our horizontal tangent, and then we start increasing again. And so it looks as though we have a relative minimum. And then finally, this last point over here where the slope of our tangent line is positive. I don't know why that became, okay, what the hell is going on? Okay, let me remove the arrow without removing the graph. So the slope of our tangent line is positive, and then we reach our horizontal tangent, and then the slope of our tangent line is negative. So we're increasing, we reach our stationary point, and then we're decreasing. And so this would be a relative maximum, right? And so we have all of the relative extrema kind of marked out on this graph. But now what we need to do is we need to think about the global extremum. Let me actually clear this graph up a little bit by removing these tangent lines because I don't want it to become a bit... Can I stop ruining the graph? Okay. There we go. I just want to clear this out a little bit so it's not too messy. But essentially, let me mark this point again. Essentially, what we're going to do is we're going to now see which of these relative extrema are the global extrema, if we have any global extrema points here. And so let's think a little bit about this. If we want to think maybe first about the global minimum, so what is the least minimum value that our function attains over its domain? Well, I mean, we have two relative minimum. We have this one right over here, and we have this one right over here. But if we're kind of just looking visually, it looks as though this relative minimum has a lower value, or is a lesser value than this relative minimum. And so what we can say is that this is not only a relative minimum, but this is also going to be our global minimum, right? And why is that? Well, we looked at our relative minimum values and we found the one that is the least relative minimum value. So it's the least value our function attains over its interval, the lowest value our function attains over its interval. or over its domain rather. And so now we can go ahead and think about the global maximum. And so here we have two relative maximum points. We have this one right over here, let me highlight it, and then this point right over here. These are two relative maximum points. But neither of these are actually our global maximum. And why is that? Well, we have to look at the endpoints of our interval as well, because we are defined at the endpoints. And so over here, we also have a maximum value at our endpoints. And although it doesn't look like we have kind of a horizontal tangent, in fact, our function is discontinuous after this point because it's no longer defined outside of this interval, that doesn't change the fact that this value right over here is actually our global maximum, right? So this would be our global maximum. Why is that? Because, I mean, if we're just comparing it to our relative maximums that we marked out, the maximums that are the points at which we had horizontal tangent lines, then, I mean, it looks as though the function value is significantly less than when we're at this, global maximum point right over here. And so we always have to be careful. We always have to check the endpoints of our interval to make sure that those aren't the global minimum or maximum, because although we may not be able to mathematically determine it, we should, in the sense of, checking for a horizontal tangent line, we should still check the endpoints of the interval to see whether our function attains its global maximum or minimum there. Now let's go ahead and do a simpler example, this one right over here on the right. And so this function is defined for all real numbers, right? We're no longer contained to just an interval of the real line. And so what we can do is we can go ahead and take a look, first of all, at its minimum values. And I mean, just thinking about horizontal tangent lines, this point right over here seems to be the only value at which we have a stationary point, right? A critical point. And so, I mean, if we're going to approximate the tangent line, it would be horizontal right over here, right? And so with that in mind, we can mark this as one of our relative extrema. And if we're going to think about its derivative, we have a negative slope for our tangent line. We reach our horizontal tangent, and then we have a positive slope. Then this would right over here be a relative minimum. Or you can just look visually, and it would obviously be a relative minimum. And then we can go ahead and take a look at any other points. And it seems as though we don't really have any other relative extrema over, over all real numbers for our function. And so we can mark this one as, can we mark this as our absolute minimum? Well, we need to check for that as well. Is this the lowest or least minimum value our function attains over its domain? Well, it seems that way, right? Because we have this point, and this is kind of the lowest point our function reaches. Over here, it seems to be kind of, if we consider this interval right over here, it seems as though our function just continues to increase significantly. And if we look over here, we have a bit of asymptotic behavior. And so here we can say that our relative minimum is also our global minimum. Now, do we have any relative maximum points? Just kind of looking at it visually. And I mean, if we're looking at it, it seems as though we don't have any relative minimum points, or relative maximum points rather, because over here, as I mentioned, over here we kind of just keep increasing. So this is going to go off, this is going to tend to positive infinity. And over here we asymptote, right? We have some asymptotic behavior. And so essentially we can say that we don't necessarily have any relative minimum, or relative maximum, so no relative maximum points. And if we don't have any relative maximum points, then we don't have any global maximum points, right? Because we need to find the relative maximum and then find the greatest of those points to determine the global maximum. So here we have no global maximum point. And so that's how we can kind of just analyze the graph of a function in order to determine its relative or its global minimum and maximum points. And that's really just the definition of absolute extremum.